We will be looking at density, a physical property of matter. Density is the amount of mass or the number of particles in a certain volume. It is the definition of matter. Matter is mass per unit volume. So to be matter, you have to have density, vice versa. This is a physical property and it is temperature dependent because as molecules get colder, they're going to come closer and closer together and become more dense because you have less volume with the same number of particles. Whereas when they start to heat up, they're going to spread apart more. So they're going to increase their volume with the same number of particles, changing their density. Therefore, knowing the temperature in which the density was recorded is essential to understand how that matter is going to behave. Here's just a fun picture of looking at the density of a lot of different objects. And you can look at whether it is a liquid or a solid object. Density still works as a property that helps us to distinguish just physical attributes for the different types of compounds. Not only is density a property, but it can also be a calculation. What it is density, which is this D, is mass, typically measured in grams, over volume, typically in milliliters. However, the units can be cubic centimeters, cc's, cubic centimeters if it's a solid, or you can even have it as this grams cubic centimeter inverse. These are all just different ways in which we represent them. Typically, for our sake, we're going to do grams per milliliter. If you are confident in rearranging a three-variable equation, you may do so. So if we have density equals mass over volume, and you need to solve for something other than density, you need to be able to rearrange this calculation. Let's say you want to solve for mass. So if we're going to solve for mass, we need to rearrange it. So to do this, we need to follow the mathematical principles of rearrangement. So we're going to get rid of the denominator by multiplying by volume. So therefore, volume equals density, oh my gosh, volume times density equals mass. What if we want to solve for volume? So when we do this, it's going to take a little bit more because volume is in the denominator and we need to be able to move out of the denominator first and foremost. So when we do this, we want to get the volume up into the numerator position. So I'm going to start with what I did above and get that volume up into the numerator position. So now I have volume times density equals mass. This now allows me to divide by density to get volume by itself. Here you have got three separate calculations for solving the three different variables in density. If you're confident in rearranging these equations, great. Know one, understand, have one memorized, and then solve for the others. If you're not confident in your ability to rearrange your variables, we have what's called the magic triangle. So the magic triangle is up in this corner where we have density equals mass divided by volume. The horizontal line means to multiply. The vertical line means to multiply. The horizontal line means to divide, just like in our unit conversions. So you will have two of these boxes occupied solving for that third. Follow the mathematical process based off the line between the two known values. Either way works. Find the method that you remember and you can work through and use that method for all your practice. Here is a calculation. I'm going to use the variable calculation first, and on the next example, I'll use the magic triangle. Like the process from the unit conversions, I'm going to follow the same process here. A 50 milliliter sample of buttermilk has a mass of 56 grams. What is the density of the buttermilk? Underline what it is that I know or was given to me. So I know we have 50 milliliters of a sample of buttermilk, and it has a mass of 50 grams. Box what it is we're looking for. So find the unit that is unknown. So we're going to look for density. Write everything down. So I know I have a volume of 50.0 milliliters. I know I have a mass of 56 grams. I am looking for density. All right, here I don't need a unit map because density is the representation of mass and volume. So it's one calculation. So density equals mass divided by volume. Plug in my values, 56 grams over 50.0 milliliters. And solving for that number, I am going to get 1.10. I'm going to double check that. No, I'm not. I'm going to get 1.12. I'm good. All right, and then the units, because they're not the same unit, they don't cancel each other out. Therefore, they have to say grams per milliliter. That is density. Last thing we have to do, check your sig figs. So we have two measured values in this problem. We have the volume and we've got our mass. We have 1, 2, 3 sig figs in our volume because each zero is significant. We have 2 significant figures in our mass. So the precision comes down to the mass. Therefore, we can only have 2 sig figs in our final answer because this is a division problem. 1, 2. So we get 1.1 grams per milliliter as our answer. In this next problem, I'm going to use the density or the magic triangle. So to show you how you can use that as a technique as well. But I'm still going to follow the same processes as before. A sample of silver has a density of 10.49 grams per milliliter and a mass of 5 grams. What is the volume of the sample? So what do I know? We know that the silver has a density of 10.49 grams per milliliter and a mass of 5.3 grams. We are looking for volume. Write everything down. So I know my density is 10.49 grams per milliliter. I know my mass is 5.3 grams. I'm looking for my volume. My magic triangle has density equals mass over volume. To help you remember what goes on top and bottom, mass and volume make a heart. So as long as you can make a heart, you know you've set it up correctly. All right, so now I'm going to go in and put what I was given. I know my density is 10.49. I know my mass is 5.3. So I plug in my numbers. The horizontal line means to divide. So I'm going to take 5.3 divided by 10.49. And I get 0.50524 blah, 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 blah. Okay, so now I need to go back and determine my sig figs. All right, so I have my density at 4 significant figures, 1, 2, 3, 4. My mass at 2 significant figures, which means my answer can only be to 2 sig figs as well. So we go 1, 2, because we've got to start with the first real number, draw my line, and that 5 does cause that 0 to round up. Now, these are going to be dropped because they're trailing a decimal. They're not holding a place for the 5 or the 1. So we want to make sure that the only numbers after that decimal are significant, and therefore there should only be 2. And there we have our volume. Now, what if an object has an irregular shape, right? We're not measuring volume with a liquid. We are measuring a solid, but not one we can use a ruler to find volume. So displacement method is one of the most common methods to determine volume, because water, the amount of water displaced, is the volume that the object is once it's submerged. So we take a measuring device, graduated cylinder, fill it up with an initial amount of water. We want to record that first. So I'm going to look at our graduated cylinder, and we're going to go through this process like we're figuring it out, right? So here I can see the bottom of my meniscus. So my largest calibrated marks are in the ones place. So I know for sure that this reading for my initial volume is at 4. The dip, or what I need to figure out, is where this, what the small lines are. So the small lines, because there's only 4 of them, goes by 2s. So 0.2, 0.4, 0.6, 0.8, so it's going to be 4.8. That is our estimated digit because we don't know where the 0.7 and the 0.9 are, so all we can say is 4.8. So then you're going to put the object, our dinosaur, into the water, and it's going to raise the water a certain amount based off the amount of volume that object has. So then we read that final volume, 5.246. The difference between the two, so 5.6 minus 4.8 equals 0.8, is the volume that that object has. What this looks like in a word problem. The density of lead is 11.3 grams per milliliter. The water level in the graduated cylinder is initially at 210 milliliter, and it rises to 285 milliliters after a piece of lead is submerged. What is the mass in grams of the lead? All right, what do we know? We know that the density of lead is 11.3 grams per milliliter. We know that the water level initially, so our volume initial, is 210 milliliters, and it rises to 285 milliliters. This means the fact that we were given 2 volumes, that this is a water displacement method. What am I looking for? Mass of my lead. In order to solve density, I need to know what my volume is. Therefore, I have to find the difference. So volume final minus volume initial is going to give me the volume of my object. So 285 minus 210 gives me 75 milliliters. Make sure you're following addition subtraction rules here. So least number of decimal places. Luckily, each number only has the ones place occupied, and therefore my calculated value only has the ones place occupied. Alrighty, so if I use my magic triangle, density makes the heart grow fonder. I am looking for mass. I know my density to be 11.3. I know my volume to be 75. Therefore, I'm going to multiply these two values together. If you want to do this in the variable way, I need to multiply by volume to move that out of the denominator. So volume times density equals mass. Therefore, I have 75 times 11.3 equals our mass. Same setup. All right, so when I do this and I multiply them, I'm going to get 847.5. Let's check our sig figs. All right, so with our significant figures, we have 3 with our density. Our volume that we ended up using only has 2. Therefore, our answer can only have 2. So we have 1, 2, the 7 causes the 4 to rise, so then that means we have 850. We do need to put the 0 in that 7's place, but with no decimal, because that 0 is not significant. The 0 puts the 8 in the hundredths place and the 5 in the tens place. So we have 850 grams. Specific gravity is another process of using density, and it compares to liquids. We always typically compare to water because water is a known value and it is everywhere. So if we can compare things to water, we can get an idea of the density of this unknown liquid. It creates a ratio. Ratios do not have units. Ratios are a comparison between two entities in numerical value. So water will be 1. The density of the other substance is going to be a number. All right, so what we look at with this calculation is we have the density of the sample over water, and we're just going to use 1 for water to make it easy. So if the density of the sample is 2.00, the specific gravity is going to be 2, which is above 1, so it's going to be more dense. If the density of the sample is 0.50, I can do my math. We're going to get 0.50, which is less than 1, so it's going to be less dense. So when we have the specific gravity, we can do a quick analysis. More dense than water, less dense than water, and we can go from there. That can give us a lot of information about the physical properties of this substance. An indirect way to measure specific gravity is to know the density of the sample and the water by mass and volume and perform the calculation on your own. We do have direct measurements though, and that's through what's called a hydrometer. Hydrometers are specially calibrated tools that will float in the substance and will give you the specific gravity of that substance compared to what water is. They're expensive, they're hard to read, but they're really important. So urine analysis can show an imbalance in your metabolism. So people who are diabetic may excrete glucose into their urine, and glucose has a higher density, sugar water has a higher density than water. So by using a hydrometer, we can test whether or not your urine is healthy very quickly without any blood work or anything along those lines. So there's a lot of ways in which specific gravity is used. Again, there is no unit because they cancel out. So a lot of times what we're going to see is SPGR, specific gravity, equals, and it's going to give us a number, 1.31. So we know that this substance has a higher density than water, therefore its properties can be X, Y, and Z.